Good morning students, I am Benil, Assistant Professor, Department of Computer Science and Engineering, Pondicherry College of Engineering. So in this video class, I am going to teach you the evaluation order of SDD. Evaluation order of SDD. Okay, so what is the evaluation order is I told you this SDD is used to clearly says that this pass tree is going to give the answer like this. For example, if I give an expression that based on that evaluation order or this SDD, it gives the answer. Okay, for example, 4 star 5 plus 3. I told you know in the previous video class I explained 4 star 5 plus 3 which some people may use to 5 plus 3 and then some people may use to first 4 star 5. So it may confusion. So SDD is clearly says the evaluation order. Okay, that means how to perform this one. Okay. So the evaluation order of SDD, you have to know about inherent attribute. Clear? I told you S attribute. What is S attribute? The attribute which derives the value from its child node. Okay, for this E derives the value from its E1, depends the value from its E1, then that is called S attribute. What is inherent attribute? I told you the value it depends on its siblings or from its parent, that is called inherent attribute. Okay, let's see one small example. S tends to TL, T tends to int, T tends to float, T tends to double, L tends to L1, ID, L tends to ID. So what grammar is this? Is type checking grammar, type checking grammar. T stands for type and L stands for language. Okay, so it may be type may be integer, type may be float, type may be double. Okay, the language is L1, ID, comma is a terminal, comma ID. ID this L1 or L is ID, one identifier. Clear? One identifier. For example, I can make it as annotated post tree like this. S tends to TL, S tends to T, type may be integer or type may be double, type may be double or type may be float, etc. Clear? So see this L dot in, that means this L or this L, it depends on the T. I mean this L depends on its type. Okay, so this L that means language, we cannot know what type of language. So it takes the value from its T. That's what I return as S tends to TL. This L depends on its siblings. Clear? It's this L takes the value from its siblings. So L dot in equal to integer. L dot in equal to integer. So what is L dot in? That is integer from the type T. So this L takes from the type T. So it depends on its siblings. Clear? Okay. See what this int is. Type is integer, double or float. Clear? And this L1 dot int. See this L1 dot int depends on its parent. Depends on its parent. So it doesn't know what is L1 dot inherent. What value is this? Type is this. So this type is depends on its parent. It takes the type from this L dot in. L dot in is integer. L1 dot in is integer. How this integer comes? It takes from its parent. How this L1 dot int come? It takes from its siblings. So one attribute it takes from its siblings or its parents, not from the child. See this L dot in not taken the value from its child. It takes from value from its siblings. So this is called as inherent attribute. Inherent attribute. Clear? Okay. So the evaluation order, you should know S attribute and inherent attribute. S attribute is I told you the value takes from its child node, but inherent attribute is value takes from its siblings or the root node. Clear? Okay. Now in the evaluation order of SDD, you should know about dependency graph. There is a term called dependency graph. Okay, so what is dependency graph is? Dependency graph explains the flow of information. Flow of information. For example, E tends to E1 plus T. Okay, the same grammar. E tends to E1 plus T. So, for example, 5 plus 4. So, E value is 5 plus 4, 9. So, it takes the flow of control is 5 and 4 is added, it placed 9. Okay. That is this graph, this arrow or this is called as dependency graph. For example, E tends to E1 dot T, E1 dot value equal to E dot value plus T dot value. Okay, so you don't confuse with E and E1, both the same. In order to differentiate 2E, that's what we are separating E and E1. Okay, right. So see, for synthesized attribute, it depends on parent, I told you. So it takes value from here. So dependency graph is this dependency graph. So this arrow is called as dependency graph. Okay, what is inherent attribute? What is inherent attribute? I told you know, for inherent attribute, it takes value from its siblings or from their parent. Okay, so this arrow is a dependency graph. For example, T tends to ft dash, and f tends to digit, T dash tends to f and ft dash. So f tends to digit, T tends to epsilon. So this is the grammar. See, this arrow, first it takes digit, and this f take value from its, the arrow goes like this. Okay, so this one is depend from their parent, depend from their parent. And second one is see 2, this digit f4, this is second evaluation, and third this and this is third one. Okay, so third. And fourth one, see this goes here, fourth one, and fifth one, this answer is goes here, and sixth, so seventh one, this evaluate, this one will evaluate, and 8, this is 8, and ninth one, this one evaluate. Finally we will get an answer. The idea behind this is, this arrow is called as dependency graph. This arrow is called as dependency graph. Okay, for dependency graph for S attribute and N attribute, synthesized attribute. Okay, so why we will say this arrow is a dependency graph? Because it clearly explains the flow of information. Dependency graph clearly explains the flow of information. So this arrow explains the flow of information. First it evaluates this, second it evaluates this, third, fourth, fifth, sixth, seventh, eighth, ninth. So 9 evaluation order is there. So this order is called as dependency graph. So you have to write dependency graph for synthesized attribute and dependency graph for inherent attribute. Clear? The another one is attribute is L attribute. You should know L attribute. So for example, A tends to B, C, D. This L attribute means it takes the value from its right to left. Okay, sorry, left to right. That means B takes value from A, not C. If takes value from C, that is not a L attribute, that is inherent attribute. Okay, so C, it takes the value from B and A, it not D. D, it can takes the value from C, derives the value from B, derives the value from A. This is a L attribute. Clear? So this mostly, if you are going for higher studies, GATE exam, they will ask. For example, they will give one B tends to ABC, and they will give one expression A tends to B, that is 1. Second one is B tends to C. Third option is B tends to A, and fourth option is B tends to B. Okay, or this B1, I can mark this B1 tends to B. So they will ask whether this which one is L attribute. So I told you L attribute is A, it can derive B, it cannot derive this B. Okay, this B1, or B1 it can derive A, it cannot derive this C. C, it can derive B, A and B. So if you take A tends to B, A, it can derive this B. Okay, so this is true, this is L attribute. B, it can derive C, whether B can derive C? No, so this is wrong. Okay, so B, it can derive A, B can derive A, so B1 can derive B. So this is true, this is true. So which one is wrong, or which one is L attribute? 1, 3 and 4 are L attributes. Okay, similarly they will ask you in a GATE question. Okay, so you should understand what is synthesized attribute, what is S attribute, that is synthesized attribute, what is inherent attribute, and you should understand what is L attribute. Okay, L attribute. One is S attribute, and inherent attribute, and L attribute. These three things you have to understand, and you should know what is the evaluation order. You should ready to explain with example. Okay, with one example. Next video class I will teach you syntax tree construction. Thank you.